Today we're going to be looking at more difficult questions involving the binomial expansion. The first thing we're going to do is quickly recap what we learned from the previous lesson. Next, we're going to find the term independent of x. Then we're going to take a look at expansions that are multiplied. Finally, we will look at a multiplied expansion with a missing coefficient. Last lesson we looked at using NCR to find the coefficients needed for the binomial expansion. Also, we found the binomial expansion in ascending and descending terms. If you're not sure about these two things, then go back and watch the previous videos on this topic. Now, we need to put this knowledge to use to find some solutions to more difficult questions. Find the term independent of x in the expansion of x minus 3 over 2x all to the power of 6. The question is asking us for the term independent of x. This means that we need to find the coefficient that does not have the term x in it. In previous examples, this is usually the first term of the expansion, where we just have a number at the beginning of the expansion. However, here you can see that there is an x and a minus 3 over 2x, so this is not so simple. To tackle this question, I'm going to write out some of the terms. With more practice, you will be able to identify the correct row needed to answer these types of questions quicker. In the following example, I'll show you how to do this in a more efficient way. But for now, writing out the terms will help you to see how this works. If we write out the first row, you can see that we obtain an answer of 729 divided by 64x to the power of 5. As you can see, there is a term in x, so this means this cannot be the row that we're looking for. Let's continue to write out some rows. Now you can see that there is no x term, so this one must be our answer. And of course, minus 135 over 2, you can just write minus 67.5, and that is our answer. In this example, we need to find the term independent of x in the expansion of 4x cubed minus 1 over 2x, all to the power of 8. This question is similar to the previous question, but this time we will use a quicker method to find our answer. First, let's split the expansion into two parts, 4x cubed and minus 1 over 2x. We will ignore the binomial coefficient for now. This is exactly what we would normally do when expanding, and we would normally increase the power of one part while decreasing the power of the other part. We know that the sum of the indices must be 8. So the question is, what two values will leave us with just an x term? Well, let's take a look. We can ignore the coefficients and just concentrate on the terms x cubed and 1 over x. So what we want is a combination that will give us the answer x. If the indices were 1 and 7, for example, when we work this out, we will get x cubed to the power of 1, which is x cubed, and the second part would be 1 over x to the power of 7. When combined, this would give us an answer of 1 over x to the power of 4, so this cannot be correct. When we try the powers 2 and 6, you can see that the first part will have a term x to the power of 6, and the second part will also have a term x to the power of 6. Which means that they will cancel out, and we will have found the term independent of x. You will become faster at recognizing which powers to use as you practice more questions. So, let's go ahead and expand using the indices 2 and 6. Don't forget to include the coefficient of the binomial expansion, and the answer is 7. Find the coefficient of x squared in the expansion of 1 plus x squared multiplied by x over 2 minus 4 over x to the power of 6. This is a typical question asked in the examination. It shows something multiplied by something else to a power. You can see that the second part is going to be our binomial expansion part, and then it's going to be multiplied by the first part, the 1 plus x squared. So, how do we tackle this question? Well, this shows us that the binomial expansion has to be multiplied by 1 and by x squared. So it makes sense that we should be looking for the expansions that when multiplied by these give us the term in x squared. This means two separate calculations. First, let's look at multiplying by 1. and then we'll look at the multiplying by x squared. For the first part of this calculation, we are looking for the term x squared, because when we multiply it by 1, nothing will change. So let's evaluate. Here I can see that if I use the indices 4 and 2, I will end up with the term in x squared. Let's go ahead and calculate the expansion. So here we can see that the answer is 15x squared. Next, remember here we're going to multiply by x squared at the end. So we want to find the term that is independent of x. For example, if the question asked me to find the term in x cubed, then I would be finding the term in x, because I would be multiplying my final answer by x squared, which of course would give me my term in x cubed. So let's evaluate what we have. This seems straightforward. If we use the indices 3 and 3, the x terms will cancel out and leave me with just the term that is independent of x. Let's go ahead and calculate the expansion. So here we can see our answer is minus 160. Now don't forget to multiply by x squared. So now we know all the parts of this expansion that contain the term x squared. Add them up and we get minus 145x squared. Remember that the question asked us to find the coefficient, so our final answer is simply minus 145. In this example, there are two parts to the question. Part 1 asks us to write down the first 4 terms in ascending powers of x of the expansion a minus x all to the power of 5. Part 2, the coefficient of x cubed in the expansion of 1 minus ax multiplied by a minus x all to the power of 5. It also tells us that the coefficient is minus 200. Can we now find all possible values of the constant a? So the first part should be easy. Let's go ahead and write out the first 4 terms in the expansion. Remember, here the question asks for the terms in ascending powers, so we start with a to the power of 5 and minus x to the power of 0. Finally, let's write our answer out properly. The plus dot 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 at the end simply shows that there is more to the expansion, but we didn't need to calculate this. Now let's tackle the second part of the question. The coefficient of x cubed in the expansion of 1 minus ax multiplied by a minus x to the power of 5 is minus 200. Find all possible values of the constant a. In the second part of this question, we are asked to multiply the expansion by 1 minus ax, and then find the terms in x cubed. If we multiply the minus 10a squared x cubed by 1, then obviously we will have the terms in x cubed. And if we multiply 10a cubed x squared by minus ax, then we will have the terms in x cubed for that part. Let's go ahead and multiply the parts that we need. Now combine them and put them equal to minus 200 and simplify by dividing by minus 10. All we have to do now is solve a to the power of 4 plus a squared equals 20. I'm going to let a squared equal u. By using this substitution, it will make it easier for me to factorize and find my solution. Now I can see that my answers are 4 or minus 5. Remember, u equals a squared, so that means that a squared must be 4 or minus 5. So to find our final answer, we must take the square root. We are only concerned with real number answers for this question, so we can ignore the minus 5. So our final answer must be plus or minus 2. Thanks for watching, and remember that there are lots more videos just like this one on Mr. Gregory Online.